In the name of Allah, the entirely merciful, the specially merciful. Dear third grade students at the Faculty of Commerce at Panha University, this is our first and second recorded lecture of statistical applications using a computer course in hybrid system. This course objective is designed to give a basic understanding of how Sbss works and how to run simple statistic analysis of data. Lecture outline. In this lecture, we will explain history for Sbss, data view type, variable value type, insert new cases, insert new variables, delete cases, delete variable, find cases, find variables, sort cases, and opening existing data in Sbss. Firstly, we should know what Sbss stands for. It stands for Statistical Package for the Social Sciences, or Statistical Product and Social Solutions. The history for Sbss. In 2009, when IBM purchased Sbss, and they decided to change the name to PASW, which stands for the Productive Analytic Software. Later, the IBM changed the name back to Sbss because it is more popular. There are many versions for Sbss. The latest one is 26. The previous one is 21, 20, 19, 17, 16, 15, 14, 13, 12, and finally 11.5. Sbss is the most widely used program for statistical analysis in social science. Sbss provides facilities which are used for data analysis in business research. It can be used for processing questionnaires, reporting in tables and graphs, analyzing means, chi-square, regression, and so on. Many analyses will be made here. It is used by market researchers, health researchers, survey companies, government, education researchers, marketing organizations, data miners, and there are many PhD and master's thesis holder analyze the data in her thesis or his thesis by Sbss program. So it's very, very important program. It can import data from many different sources such as Microsoft Excel and SAS and many programs. Provides analysis tools to generate reports, charts, plots, descriptive statistics, and run advanced statistical analysis. There are basic operations in Sbss, which is basic steps in data analysis. Through it, we can add or delete a variable. We can add or delete data. And we can save the data, import the data from Excel file. We can check the data entered and we can sort the data. Finally, we can transform the data. And we will explain all of these topics during the course. Let's start with the starting of Sbss. There are a number of different ways to start Sbss. The simplest way is to look for an Sbss icon on your desktop. Place your cursor on the icon and double click. You can also start Sbss by clicking on Start menu and move your cursor to All Programs. and then across to the list of programs available, see if you have a folder labeled SBSS which should contain the option SBSS Statistics 20. This may vary depending on your computer and the SBSS license that you have. SBSS will also start up if you double-click on an SBSS data file listed in Windows Explorer. These files have a .save extension. When you open SBSS, you may encounter a front cover screen asking, "What would you like to do?" It is easier to close this screen by clicking on the cursor in the top right hand corner and to use the menus. Set the simple introduction to SPSS. Now we should enter to Spss window and try to explain what is in this windows. Firstly, we can open the program from the start menu. We will click the name of this program, which is SPSS 20 version, and enter on it. The first window will appear is like this. We will explain every point here, but not now. We will during the course explain every point. Okay? As we said in the lecture or in the face-to-face lecture, that we can open an existing data source by entering on open an existing data source. This is already saved sources saved by SBSS. It is downloaded with SBSS. Opening an existing data file. If you wish to open an existing data file, click on File from the menu across the top of the screen and then choose Open, and then slide across to Data. The Open File dialog box will allow you to search through the various directories on your computer to find where your data file is stored. You should always open data files from the hard drive of your computer. If you have data on a memory stick or flash drive, transfer it to a folder on the hard drive of your computer before opening it. Find the file you wish to use and click on Open. Remember, all SBSS data files have a .save extension. The data file will open in front of you in what is labeled the Data Editor window. More on this window later. I'll explain it later in this lecture. Working with data files. In SBSS, you are allowed to have more than one data file open at any one time. This can be useful but also potentially confusing because there is more than one data file. You must keep at least one data file open at all times. If you close a data file, SBSS will ask you if you would like to save the file before closing. If you don't save it, you will lose any data you may have entered and any recording or computing of new variables that you may have done since the file was opened. Turning to the next point, which is starting a new data file. Starting a new data file is easy. Click on File, then from the drop-down menu, click on New, and then Data. From here, you can start defining your variables and entering your data. Before you can do this, you need to understand a little about the windows and dialog boxes that Sbss uses. When we want to save a data file, when you firstly create a data file or make changes to an existing one, for example, creating new variables, you must remember to save your data file. This doesn't happen automatically. If you don't save regularly and there is a power blackout or you accidentally press the wrong key, it does happen. You will lose all of your work. So save yourself and save your effort and save regularly. To save a file you are working on, go to the file, which is in the top left hand corner, and choose Save. See here, this is the data editor toolbar. We can click on it and it can make all the transaction we want by one click. This is the data editor menu. And finally, as we see, this is the data view or variable view tab, and we will explain it in the next slide. But if we want to enter the data manually or by our hand, we can click on cancel and enter quickly to the program. This window will appear. There are some small pictures like this. We should know every icon denote to what. For example, this icon, it is denoted to save file, open file, dialog recall, redo, and by try and error we will know all of these terms, what they mean. Entering and manipulation of the data. We will say an introduction or a simple introduction to this point. Entering data into Sbss is a two-step process. Firstly, you define what sort of data you will be entering, and then you will enter the actual numbers. And we studied in the first year and in the second year in descriptive statistics and in applied statistics the measurement of data. We know there is quantitative data and qualitative data, and we know the first level of data levels is nominal. Nominal, it is easiest one to understand. As we know, nominal variables, it isn't it is without any quantitative value. When we say مثلا, for example, brown, like what's your hair color, What's your eye color? We can say that it's brown, it's black, it's blonde, it's gray. When we said what is your gender, you can say male or female. Okay, so we can't order them. Number 2, the ordinal data. The ordinal data, by its name, we can order the value of them, like the grades of students. We can say that fair, good, very good, and finally excellent. We can say that unhappy, happy, and very happy. We can order them. Interval data or Toolbar scale. It is a numeric scale in which we know both the order and the exact difference between the values. For example, is Fahrenheit or Celsius temperature, because the difference between each value is the same. For example, the difference between 60 and 50 degrees is a measurable 10 degrees, right? When we make a difference between 60 and 50 degrees of the weather, for example, it is measurable, it is 10 degrees. It is the same of the difference between 80 and 70 degrees. Okay, finally, the ratio. It is the upper level of measurement. Okay, ratio have a clear definition of 0. Ratio is have a clear definition of 0. Like for example, الوقت والهيت والduration, many things for ratio scale. So now we know the difference between the measurement of or the levels of measurements of data. Okay, so number 2, you can organize your data into cases. Each case is made up of a collection of variables. Firstly, you define the characteristics of the variables that make up a case, and then you enter the data into the variables to make up the contents of the cases. This chapter shows you how to work with this technique of getting data into your system. Here, the data editor. The data editor provides two views of data, the data view and the variable view. Information can be edited or deleted in both views. Data view. This view displays the actual data values or value labels as presented here. Variable view. This view is for entering variable definitions and the characteristics of variables. Each variable characteristic has a default. So, if you don't specify a characteristic, Sbss fills one in for you. However, what it selects may not be what you want. Let's look at all contents in variable view. The first one is name. It is a unique name of each variable. The names should be different. It is best to have a short variable name that is easily recognized as related to the underlying variable. Maximum of 64 characters, upper and lower case letters, digits, and some symbols. Name must begin with a letter or @ symbol. No spaces allowed. Underscore is often used in its place. Punctuation marks are allowed. For example, full stop. It can't be one of the few reserved keywords like not. To define the name of a variable, follow these steps. Number 1, click on a cell in the name column in the variable view window. Number 2, enter the name for the first variable as, for example, ID pref, and press the enter key. Type. It specifies the type of data for each variable. The original setting is the most frequently used type. The numeric type, which refers to variable whose values are numbers. However, we can change to numeric like this, comma like this, dot like this, scientific notation, date, dollar, custom currency, or a string. And this is a window of the variable type. The third content of the variable view is width. The field width. To define the width of a variable, follow these steps. Click on a cell in the width column for the corresponding variable in the variable view window. Enter the number of characters you want to use to define the variable, or click on the up and down triangle to change the value. Setting the width of a variable. The fourth content is decimals. Number of decimals in case of numeric type. To define the width of a variable, you can follow same previous instructions but on the decimal field. Here, the data editor. The data editor provides two views of data, the data view and the variable view. Information can be edited or deleted in both views. Data view. This view displays the actual data values or value labels as presented here. Variable view. This view is for entering variable definitions and the characteristics of variables. Each variable characteristic has a default. So, if you don't specify a characteristic, Sbss fills one in for you. However, what it selects may not be what you want. This figure will represent what we said in the previous slide. Number 6, which is the 6 content of the variable view, is missing if we don't have data because, for example, a respondent refused to answer. User missing values are flagged for special treatment and are excluded from the most calculation. Columns. It is the number of characters for the column width. Alignment control the display of data. It can be right, left, or center. Measures here, it is the scale of measurement, which can be nominal, ordinal, interval, or ratio scale. In the SPSS you will find the nominal, ordinal, and ratio measures. The first one, nominal scale. Numbers are labels or groups or classes. Simple codes assigned to objects as labels. We use nominal scale for qualitative data. For example, professional classification, geographic classification, for example, blonde, brown, red, black. A person with red hair doesn't possess more hairness than a person with blonde hair. Ordinal scale. Data elements may be ordered according to their relative size or quality. The numbers assigned to objects or events represent the rank order, the first, the second, the third, and so on. For example, top lists of companies. Interval scale. There is a meaning of a distances between any two observations. The 0 point is arbitrary. Negative values can be used. Ratios between numbers on the scale are not meaningful, so operations such as multiplication and division can be carried out directly. For example, temperature with the Celsius scale or Fahrenheit scale. The fourth measurement is the ratio scale. This is the strongest scale of measurement. Distances between observations and also the ratios of distances have a meaning. It contains a meaningful zero, for example, mass and length.